Good evening, everybody. Oops, I'm having trouble launching my Logitech here. Hang on a second. There we go. Good evening, everybody. Welcome to the Virtual Night Sky, our version of the Virtual Night Sky for February the 23rd. It's 2022. Did anybody sort of notice yesterday at 2:22 in the afternoon, it was also 2:22:22? That probably doesn't happen very often. And I want to sort of like welcome you to the program tonight. My name is Rick Alling, and I am the director of the Marston Exploration Theater. I work for the School of Earth and Space Exploration at ASU, and you are visiting what we call a virtual night sky. We do this every other Wednesday night at 7 o'clock. Many of you have done this many times. Thank you for your patronage, and I hope we have some new people tonight. I hope we have some people that are just checking us out for the first time. I'm going to introduce some of the people that are going to be with us tonight. Kim Baptista is our webmaster. She's the one that has been doing the communications and getting everything kind of organized for you. I hope you sort of found it easy to get on and understand sort of how to work the program here. We do not use chat, so if you have, but we do encourage you to do question and answer anytime you want. So you have a question and answer button down at the bottom of your screen. Go ahead and press it, ask anything you want, make comments if you want. We monitor that during the program, and we sort of answer questions as we go. We also bring questions forward to the group at certain breaks during the program. So make sure you use that. We do closed captioning, and if you don't want it, then you're in charge of that. You can turn it off of your screen, but we do closed captioning because it's easier for us to handle the recordings and things like that afterwards. Meg Hufford is with us tonight. She's my colleague, and she helps organize things, and she runs the docent program at the School of Earth and Space Exploration. So many of the student employees that work with us and work on the team are also part of that program. So that's important. You're going to see lots of presenters tonight. Alex is going to be showing us a little bit about the night sky and some planets to go look for in the early morning. Alicia is going to give us a little update on Pluto and if Pluto's a planet or not. Tonight's about planets, you know. And Armand, one of our newest participants, is going to kind of give us a little demonstration or a little program about exoplanets. Remember, planets is our thing. If my wife pointed out to me that Alex, Armand, and Alicia are the A team. Did you get it? Yeah, okay. And so I also have a special guest from Fountain Hills, Joe Bill, and he'll be on for a little bit, give us an update on dark skies. So we've got a lot to cover. Remember, in the first part of the year, we've been trying to give everybody just sort of the basics of how to look at the sky. What's up there? How does it work? And the very first program we did in the year in January, we talked just about stars, how to find stars, where are they, what are they, and how do they work through the seasons. The next couple weeks later, we tackled the moon. We looked at all the orbital elements of the moon, how to observe the moon, and what was important about that. 2 weeks ago, we talked about the sun, and it was all about solar things and solar calendaring on the horizon and those kind of things. Today, we're tackling planets, and I'm going to just share a screen real quick for you. I have a quick little PowerPoint that I'd like to show you here. Hold on a second. Share screen, this one. Here you go. Sorry. Hold on 1 second. I think I got it now. I just kind of wanted to show you there are 5 planets that have been known since prehistory. And those are the ones that are observable by us in the night sky. And so other planets, we know about them, but you can't really see them. And this program is a lot about kind of, you know, what you can do from your backyard. We're trying to give us something to go look for, something to go see, something to appreciate. And so tonight I'm going to show you how to observe these 5 planets. But before we get there, I'm going to just kind of show you some things about this. Planets are wanderers. That's kind of, it equals the same thing. Planets means wanderers. And these 5 planets are known before any written record. our first literature was Hesiod and Homer, pre-Greek times, about 800 BC. And by the time we started having written record, and by the time we started understanding how philosophers and scientists kind of understood their world, planets were already known. These 5 wanderers were known to us. They also included the sun and the moon. And the reason that they were able to do that is because these were objects that they didn't understand were different from planets. They're just objects in the sky. And the reason these are called wanderers is because they change position against the background of fixed stars. That's sort of one of the trait of planets, and it also happens with the moon and the sun. So to ancients, they had 7 planets. And it is no coincidence. I'll share a little trivia with you, but that actually relates to your days of the week. 8 planets, 8 days of the week. It's kind of one of those. Let me just sort of do this. So Sunday and Monday are pretty well understood. That's kind of easy. That's kind of easy to see. Saturday and associated with Saturn is also. For the other ones, we probably have to sort of like add a little Spanish language to it, but you can see that there's a relationship here. We get the names of the days of the week are both Germanic and Latin, and so both things have taken place here. We settled into a 7-day week about in 200 AD. That was during the Roman Empire days. And the Romans already knew the planets. They already named the planets after their gods, and associating these with the week was pretty important to them at the time. We also added later a couple of other planets. Uranus was not discovered until 1781, and Neptune came to be in part of our understanding in 1846. So all of those now are the 8 major planets. The sun and these planets, the things you're seeing on the screen right now, are 99.985% of the mass of the solar system. It's pretty amazing to think about. And almost all of that is the sun. The sun is 99.87% of the mass of the solar system. So if you're sort of sorting out everything, these objects make the main mass. And this is where the gravitational attraction of the sun holds these planets into orbit, and they accreted after a debris disk early on in our solar system, accreted into the planets. They've been moving and orbiting ever since. And that leaves a 0.15% of our solar system mass is everything else. All of the asteroids, all of the comets, all of the dwarf planets, all of the Kuiper Belt objects that are swimming around, and everything you can think of, all the other moons in the solar system, a tiny, tiny, tiny fraction of the mass. So the solar system is a sun, major planets, and that is the big deal. I wanted to ask you, have you ever thought about this? Do planets have personalities? Don't you get asked that all the time? I get asked that all the time. And what I'm going to do tonight is just kind of show you some of the orbits of planets, how they relate to each other, how we see them in the sky, what's going on in space, and how do their orbits relate to how they act, how do we get to sort of observe them and watch them. And so that's how we're going to do that. Before the program started, I think you were listening to some music, and let me introduce you to somebody here. Have you ever heard of Gustav Holtz? This is I looked through many, many images of Gustav, and this is the most lively I could find. I don't think he was a very vibrant character. But he sort of in middle life kind of decided to tackle these planets. He got very interested in the planets. He also got interested in astrology. Astrology is not a science. That sort of relates to how we react to our planets and those kinds of things. He actually did readings and astrological predictions for his friends. And he also wrote a suite of symphonic music that was in movements, and the movements related to the planets. And so he actually sort of put a personality on these. And if you ever go listen to this, if you sort of make your way through the entire orchestral work, it was released for the first time in completion in 1920. So by the time he came around to those planets, Uranus and Neptune were here. And he sort of gave them this idea. And the winged messenger makes sense for Mercury. We relate it to the Roman god that has the little wings on his feet and he flies around. Venus, the bringer of peace, is also associated with the goddess of love and beauty. Mars, of course, the god of war, and they're the bringer of war. Jupiter, I've always sort of thought of as a fatherly figure. He thought it was the bringer of jollity, and Saturn, the bringer of old age, the musician and the mystic. So personalities, yeah, we've always associated the planets as kind of personalities. Let's take a look at these 5 planets. I'm going to change share screen real quick, just because I have to do that. And you'll see something like the same image turn up again on another screen. Hang on 1 second. Got it. And so I'm going to kind of switch over to a different computer here so you can kind of observe what we're doing. But these are the planets I just wanted to cover tonight. Let me just turn this off. We're going to sort of find ourselves in a solar system. And for those of you that have seen the shows before, this is actually a program called Skyscan. It's a computerized database of all the planets and all the stars and everything in the sky. And I like to use it. I'm going to size up the planets so that they're a little bit more visible. And I'm going to take us to right now, today. Here's what those planets look like in their orbits. We just kind of like move them in time a little bit, center the sun for a moment. You can sort of see everything is racing around in the same direction, but all the planets move in at a different speed, at a different rate. The planets that are closer to the sun move faster. The planets that are further from the sun move slower in their orbits. I'll show you a little slide here that sort of quantifies that for a little bit. But I want you to remember, as we look at the sky, the point is we're looking at moving objects. They're wandering against that background of stars, right? But we're also looking at the planets from a moving object. We can't stop the Earth. We can't observe this. We're moving too. So everywhere we go, and every time you see a planet in the sky, it's a relationship between us and them, and we're both part of the same system. I'm going to zoom in here real quick, just fly in a little bit. And so as you can sort of see here, that is the Earth right in front of you. Would you like me to label these for you? Just so, let's see, I can do that. Let me just sort of put some labels up here so you can see. And I want you to sort of think about this for a second. This is where we are today, where the orbits of all these planets and how they relate to each other just exactly at this moment. If I were to draw a line, I think you've heard me talk about this before. If we were to, let me just stop this movement a little bit. Hang on a second. It's organized about right there. If I were to draw a line from Earth through the sun and out into space, just kind of like imagine a line drawn through here. Everything on this side of the screen is visible to us in the morning. Everything on this side of the screen, the other side of the line, are evening objects. And it shouldn't be a surprise to you that just right now at this particular time, if you want to go out and observe planets, you're going to have to be a morning person. And I'm going to show you a little bit of a scene so you can see how that works. Jupiter is just about to move behind the sun. If I just move forward in time a little bit, I think I can illustrate that for you. As we move forward just a little bit, the Earth is moving left to right. We just positioned the sun in between us and Jupiter. So it's been lost into the evening sunset. I'm only about a month forward now in time. And what I can sort of show you is there's this sort of funny little magical time that doesn't happen very often coming up, where all of the planets are going to be morning planets. Every single one of them is going to be an object in the morning sky. You're not going to see any planets in the evening. I'm going to now do a little thing here, a little trick that we can do here. I'm going to land us down on the Earth, and we're going to look at the eastern horizon. We'll see how these planets play in the sky on the horizon. Let me just sort of do this. First, I'm going to land. Then I'm going to flip ourselves over to the east. We're going to give ourselves a little bit of a horizon so we can see that happen. I'm going to move forward, and backward in time a little bit, and I'm going to just kind of turn on the labels for a couple planets here. So we're going to see Mercury, Venus, Mars, and Jupiter in this scene a little bit. So what's happening here is you're looking at the morning sky, you're looking at the eastern horizon, and if you look, you might be able to see really close, you can see there's a little bit of a glow of the sun here. So I've set this up so that we're looking at Venus in the sky, and this is actually on January the 12th. This is about a month, 6 weeks ago, Venus appeared in this part of the sky. And now what I'm going to do is I'm just going to move forward. And I wanted to talk about sort of that personality thing again. Mercury and Venus are going to move through the sky very fast because they actually have very fast orbits around the sun, right? Mars is going to move a little bit slower because it's a little bit slower. In a moment, this scene is going to include Jupiter. It's going to sort of arrive in the sky. Remember when I was showing you when we were in that orbital view, how the sun was moving, the Earth was moving and putting the sun in between it and Jupiter. As we move out sort of the other way, then we're going to be able to see Jupiter in the morning sky. Let me just play this out. I'm going to turn on some tracks so you can see what's going on. I'll leave labels going. This is January. I'm just going to move forward a little bit and see if you see what happens here. So this is basically where Venus is in the morning sky over the course of the next 9 months. You see Mercury showed up in the sky and then it's moving right back down again. Remember that sort of Mercury winged foot, fleet of foot. Now you see me, now you don't. Jupiter just appeared in the sky, right? And started coming up. That's because we're moving around away from the sun. But watch what Venus does. Watch what's going on here. There comes Mercury again. Now, Mercury went all the way around the other side of the Earth, was an evening object for a little bit, and then popped up. It was a morning object again. But Venus hangs in the sky for a long, long, long period of time. Once you start to see it above the eastern horizon, when it's a morning object, they call it the morning star, it stays up for about 260 days. I have a little diagram for you so you can see that. Looks like I have to, hang on 1 second, I have to move back so you can see what it looks like. In the Venus cycle, you can see that right now, here's the Earth, here's the sun, and here's the orbit of Venus. And so you can see in this diagram, it's about right here right now. It's a morning star and will be there up until, well, I just moved you forward to just do the equinox, September 22nd. So it'll be in the sky up until then at least. And then it goes behind the sun for about 50 days, and then it appears in the western sky. And it does the same thing. It just does this sort of moves above the horizon, moves across the horizon, and then dives back in. And then we lose it again in between the sun for a couple of days. Last year, when we were watching Venus, last October and November, it was an evening star. You might remember, we're kind of keeping an eye on it, seeing where it was. It's very, very exceptionally bright. So if I had to go do a characteristic of Venus, it is really the brightest object in the sky next to the sun and the moon. And I'm going to turn back to the east here a little bit. So when it appears and when it's sort of in the sky, it's exceptionally bright. People call me a lot. They say, what is that really, really super bright object in the sky? I'm going to do that one more time, but this time I'm going to show you something else here. I'm actually going to add the orbit of Venus. Let me go back to that setup date. And now, so this is January. I'm going to move forward in time and watch what Venus goes. So let me just show you this to give you a little hint. This part of the orbit is on our side of the sun. And then you'll see it'll go up and around the top of its orbit. And this side of the orbit is the back side of the sun, if we wanted to do it that way. Let me sort of move forward and see where this goes. So Venus is sort of, there's Mercury sort of doing its travel. Venus is sort of going up. Remember, it's closer to us than the sun now. And now it's about even with the sun. And now it's going around its orbit. It will drop back behind it. That's what gives it sort of this characteristic. I love that we're going to have a conjunction with Jupiter in early May, and Jupiter is going to have a conjunction with Mars in late May. So we'll be talking about that on this particular show. The conjunction is when those planets move right next to each other. Anyway, so the characteristics of these two objects, the fast-moving Mercury and the fast-moving Venus, they never get very far above the horizon from our point of view. They're always close to the sun, at least relatively. Mercury far more close than the other. Mercury is smaller and dimmer, so it doesn't really distinguish itself. It looks like just an inconspicuous star in the sky. But the two of them sort of have those personalities. One is very, very quick. You see it for a little while, it goes away, it darts behind the Earth, it darts up the other side. I'm going to kind of just change views here now a little bit. We're going to get back out into space. And I wanted to show you a little thing about Mars that I think is kind of important. The center of the Earth, we're going to have to lose that thing and move back up. And so Mars is the god of war, and Mars has always had a very, very funny relationship in the sky. It's reddish, right? So color matters, and it is. Let me just sort of like light the orbits of the Earth and Mars here. And the relationship between the two of them, Earth and Mars, is very, very important. You can see that the orbits come very close to each other for part of those orbits. I can sort of like blow these up again a little bit. Planet size up so you can see them. And so when we pass in this orbit, when the Earth and Mars are sort of moving through space, one quick second, I'm going to center the sun. You can see that our orbits come close to each other, or the planets come close to each other when we pass. The Earth travels, does this orbit in a year. Mars takes almost 2 years to do its orbit. So that means approximately every 26 months, they come in this really, really close moment where they're closest to each other. It shouldn't be a surprise to you that what happens at that close opposition is when we launch a lot of spacecraft to Mars. Last time it happened, 3 spacecraft launched to Mars, including, of course, you guys know, the Perseverance rover that ASU has a special part of. We can expect that that's going to happen again. I'm going to actually sort of just go to a specific date late in this year, and it's going to be middle of August. And we're going to be getting prepared at that time to do one of those close oppositions. Let me sort of line you up here so we can get Mars and the Earth in alignment over here. I'm going to light up a constellation, the constellation of Taurus in the background, just a little stick figure, and and I'm going to shrink the planets again so that they're sort of like lower again. Yeah, this isn't showing up like I'd like. One more quick second, I can make an adjustment here. I'm going to turn the Earth's orbit off. I see what the problem is. I need to center the Earth. So there's the Earth, and Mars is out here in the distance. I'll label it for you. Oops. There's Taurus. There's Mars. There's the Earth. What I'm setting up is a thing where Mars does this really very, very funny movement in space. And not only is it red, but it has this characteristic of actually changing direction. And when it does that, it also gets closer to us, and it gets very, very bright. I'm sorry it takes so long to set some of these little simulations up. I'm going to turn on orbits here. I'm going to actually sort of just move forward in time a little bit. And just watch what happens to Mars as it moves through space. So it's interacting with the constellation of Taurus right now. It's going to move forward as it's moving through its orbit. It's going to come to a stop, turn around, go the other direction for a while. We call this retrograde. And what's happening here is, in effect, remember I showed you that we see Mars as an object from a moving object. So we're passing Mars at this particular time. And so we get to sort of see it move through that funny little shape there, retrograde motion. And in its personality, if you want, what Mars does is it changes direction. It gets very, very bright for a period of time. And I think for ancient people, that would have been a very, very scary moment. And not understanding what that actually does, how that actually works, would be a problem. I'm just going to show you just a couple of other slides here. I wanted to show you the orbital periods of all these. So Mercury is very, very fast. It orbits around the sun in 88 days. You saw a little sample of how it appears in the morning sky, then disappears. And then some short time later, several months later, it'll do the same thing, just reappear and go. Venus, we watch that orbit, and so how it appears in the sky, moves across the whole thing, and it sort of sinks, dives back into the sun. And Mars, 23 and a half months for it to do its orbit, but about 26 months for us to come to that inferior conjunction where we get to see Mars do its retrograde motion. And that's its closest to, so that's why it gets brighter. Jupiter is actually going to move very, very slowly through the sky. And in a almost 12-year cycle, that means that Jupiter will move between one constellation of the zodiac about every year. And so when we get to see it again in the morning, Alex is going to show us that in a minute, it will be in a constellation. Last year, it would have been in the constellation just before that. And next year, it'll be in the one after that. So, and that goes through a 13-year cycle before it goes back to being. And then Saturn is a lot further away. It's bright enough to see, but in a 30-year orbit, we're going to see it virtually in the same part of the sky all the time. So it will be associated with a constellation in the sky, rise and set at a certain time of year and not really change very much. So these are the planets you get to see. These are their orbital elements, and we showed you a little bit about how that looks in space as they're moving around, what we get to see and what we don't. So I'm going to turn the screen over to Alex, and he's just going to kind of give us some night sky, or in this case, morning sky, things that we can look for in our analysis to look for planets. Stop share.
Yeah, thank you, Rick. We're going to share. We've actually shared this program before, but just for those who aren't familiar, this is Stellarium. This is a free program. Let me get a bunch of these windows out of your way so you can see it better. This is a free program you can find online. They actually have a version that you can view on your web browser, either stellarium-web.org, or this is the full program that you can download on your computer, stellarium.org. Great program to just see what's in the night sky. This is our night sky right now. Oh, there's our night sky right now. This is looking to the southeast. This is in Arizona. But what I'm going to do is I'm going to fast forward time a little bit. We're going to get these stars moving. And we're going to start looking at our early morning. We're looking at about 5 or 6 a.m., right? Right before the sun starts to rise is when you're going to start seeing things come up. You're actually going to start seeing a pretty familiar thing. You're going to see the moon first. Right now we're hitting midnight. We're seeing this is actually kind of if you're living in a metropolitan area, this is kind of what you'll be able to see in terms of brightness. There's our moon rising in the sky, and then we're going to start to see some planets. The first that is actually going to come up is going to be the bright morning star right now. Sometimes it's the evening star. This is Venus. This is going to be one of the brighter objects in the night sky besides the moon. You're going to have Mars below it. It's not going to be as bright, but it's still going to be visible. And then you're going to have Mercury, which is also going to be brighter than it sometimes is throughout the year, but still not as bright as Venus. Oh, and actually, I think you're also going to see Saturn, but just real quick, just kind of a little Easter egg. You might see, if for some reason you decide to get up this very next morning, let's see, it's going to be at 6:30. There's a telescope moving, and it's the Hubble Space Telescope. What a treat. So that'll actually be there this morning too, but it'll pass right between these planets. And then finally, right before the sun rises, you're going to have Saturn. Now the thing is, Saturn's so close to the horizon and so close to the sun right now that you're actually not probably going to be able to see it. It's going to be blown out by that early dawn light, and once the sun gets up, then it will be completely invisible. But Venus, you have a very good chance of seeing because it's very bright up early. Mars is there with it. Mercury, you may or may not be able to see it depending on your location and what time. And then Saturn, unless you have maybe some specialized equipment that you are really powerful, you might be able to see. And then, as Rick mentioned, Jupiter's actually pretty close to the sun. So you, unless you're using some sort of filter, or even then, let's see, I can't even see it from here. There it is. It's completely blocked out by all the sun's light. So, yeah, Jupiter is not one of the visible planets right now. But make sure to catch Venus, Mercury, Mars, and unfortunately, probably not Saturn, but maybe if you get lucky. But those are all in the early morning between about 4:30 and 6:30 in that morning.
So I'm afraid for everybody, at least for the first half of the year into July and August, if you're going to be a planet observer, you've got to get up before dawn. And there is a big show going on there. So I'm going to encourage people to maybe do this, check it out at least once a week to see what's going on. But as these planets change position against each other and against the background skies, really just before dawn, you'll be able to see sort of, if you want, you'll be able to see those personalities come out. The different planets will do different things, show different attributes, and do that. Alex, can you move forward just to like May 1st? Same scene, same place. That's where we're going to start to see some of those occultations, and those are really kind of fun to see, or conjunctions at least. An occultation.
Yeah, here we go. I'm assuming you're talking about between Venus and Jupiter.
Yeah, so Venus and Jupiter there, but then about 4 weeks later, and those will be very bright. That'll be kind of fun to see. And then about 4 weeks later, you'll see Jupiter and Mars. See Mars up just a little bit above it up there. And so that'll be the motion. But we'll call people's attention to that. Keep watching. We'll have more programming about that, and we'll kind of give you some things. But I guess the big alert for now is it's fun to follow the planets. It's fun to check them out. It's fun to see how their orbital relationships sort of change the way we get to observe them and what they do against the horizon. Especially Venus is fun to watch over a period of time. So that's a really good place to be. Thank you, Alex. Is that all? Is that what you have? Is that good? All right. I think we're going to launch a poll. Is that what we're doing? We're going to turn it over to Alicia.
Yes, Rick, you are right. That's what we're going to do. We're going to launch a poll. And so our first poll question is, how many major planets are in our solar system? So go ahead and answer that question. And while we're waiting for that, did we want to take a question?
Yes, everybody was
from
paying
the
attention.
audience members. Yeah, it looks like a majority of us got it right at 8. So I'm going to go ahead and end this poll. There are 8 major planets in our solar system, and we're going to talk about that more in just a minute. But I'm going to launch our next poll, which is, where was the discovery of Pluto made? And while we are filling this out, I am actually going to have Alex come back and do a question for us. Sorry, Alex, I just had you come on
back and forth. What's this about?
I'm so sorry.
So
are there any questions for us?
Yes, we have a question. We have a question from Hannah. They ask, is there a certain pattern that you can tell the planets are in, or how do you remember the ordinates of planets? I'm assuming this might either be a relation in the solar system, or it might be in terms of the night sky, how we view that order as well. Maybe cover both.
So really the thing to do is I always encourage people to look at both what we get to see and what's happening in space. And you'll hear me say that over and over again. And one of the things we do with our youth programs and our education programs is we try to show both. Here's where the planets are. Here's what they're doing. Here's how they're relating to each other in their orbits, what's going on in space. And then bring us right down here and put our feet on the ground and look up and say, okay, this is what we get to see. Like you remember I was showing you essentially Venus. We were able to watch it move through its orbit in that simulation, right? And so what we get to see is it just every day gets a little bit higher above the horizon, then it sort of drifts across and follows the sun and does that. What's happening in space, of course, is just those two planets are orbiting together and the like. So anyway, I really encourage you to download and kind of get some one of the Stellarium programs, or there's free ones. There's ones that don't cost very much money. There's a ton of them. NASA actually website, the JPL website have programs you can just like go online and find all this information. But kind of keep an eye on what they're doing and check it out every once in a while, and then predict in your own mind, okay, a month from now, this is going to move here, and this is going to be over here, and this is going to be over here. How am I going to be able to see it from the Earth? And that's really, it's a good, really way to think about it. So I'm going to turn it over to Alicia about another. Is it a planet or is it not a planet, Alicia?
We're gonna find out, but just for a little acronym, I know that there's a couple on the internet that we can find that have our 8 major planets as we talked about. So I'm gonna go ahead and share my screen now for this presentation and our current events, which is very exciting. Maybe. No, it doesn't look like the audio worked. Sorry about that, folks. We tried it.
A work in progress.
Earlier, but
Alicia has added snappy music to current events. So.
All right, so breaking news. Happy 92nd discovery anniversary to Pluto, and we did give it away earlier. Pluto is not considered a major planet. It is considered a dwarf planet. But on February 18th in 1930, Pluto was discovered up in Lowell Observatory, which is in Flagstaff, Arizona. If you've never been up to Flagstaff, Arizona and taken a tour of the Lowell Observatory, I highly recommend it. It's definitely worth the drive if you're in the area. But like I said, that was discovered up at Lowell Observatory, or Pluto was discovered up at Lowell Observatory in 1930. And unfortunately, that would be a short reign, as in 2006, we did reclassify Pluto from a major planet to a dwarf planet. So going back to our poll question, how many major planets do we have in our solar system? Well, we can count them together, but the answer is 8. We have 8 major planets, and unfortunately, Pluto is not one of them. And so at this point in the show, I like to ask, is anyone upset that Pluto is no longer considered a major planet? And so I guess it's good that it's virtual. So I don't get to know for sure who's upset or who's not, but I know it's a very emotionally charged issue. So I'm going to try and explain to us why Pluto is no longer considered a major planet. So the first reason that I can explain to you is its orbit. So if we look at the orbit of the Earth if we look at the orbit of our major planets, so our 4 rocky inner planets and our 4 outer gas giants here, we're going to see that they all kind of lie on the same plane. And so what that tells us is that all of our planets, our major planets, are made roughly of the same material and at the same time. And so what you can't see also in this graphic is that all of the planets are orbiting in the same direction, right? So all of our planets are going the same way. Here we have the orbit of Pluto here in this purple elliptical orbit that we see, but unfortunately it's not on that same plane. It's not quite on the same plane as our major planets, excuse me. And so because of, well, that is one of the reasons why we no longer consider Pluto a major planet, but there are a couple other reasons. So let me go on next to say that compositionally it is different than our other major planets. As I mentioned, we have our 4 rocky inner planets and then our 4 outer gas giants. And then we have Pluto, which is cold and icy and just does not quite necessarily fit in that same composition category. Moving along, if we're taking this image of if we're taking a scale model of our solar system, we're going to see that Pluto way out here is definitely much smaller. So size does factor into this, although that is not the only reason. that we decided to demote or to recategorize Pluto. And another reason is just out of sheer kindness, because if we were to reinstate Pluto as a major planet, we would have to make hundreds of other objects planets, and just think of the children, right? That's a lot for them to have to memorize. I have trouble with the 8, let alone 309 or more. So for all of those reasons, and even more, we've decided to reclassify Pluto as a dwarf planet. So to plagiarize myself from the last virtual night sky, revolve in peace, Pluto, still #1 in our hearts, just not #9 on the chart. So with all of that said, I'm going to go ahead and stop sharing. And I hope that helps explain why Pluto is no longer a major planet. Rick, I'm going to pass it to you now.
For whatever reason, my mute is having trouble coming back. Thank you, and that's really great. And yeah, in other programs, I think we've talked about other dwarf planets that are in the same area of Pluto. And so, Alicia, I think you're absolutely correct. There's, we're discovering more and more and more and more different kinds of objects and different types of objects. But I kind of like, one of our professors at the school, Steve Dash, and he has this, he sort of still thinks of Pluto as a planet, but just a different kind of planet. And I sort of like to think of it that way. I think we have 4 interterrestrial planets, rocky planets, and they have personal characteristics, gas giants, and they have characteristics. And there's this other class of object that Pluto fits into very, very nicely. It's still orbiting the sun. It still has planet in its name, whether you call it a minor planet or a dwarf planet. So anyway, I'm going to go with that. And the actual number of planets that we have known and understood through time has changed consistently, as you saw that at the beginning of the show. So thank you, Alicia. That's really great.
Thank you.
I second that idea to go to Lowell Observatory. It's amazing. It's a wonderful place to visit. And if you haven't yet, well, please do that. I wanted to, I'm going to just switch it over. I'm going to invite Armand to the screen because one of our newest members and he's a student in our program, kind of new to us, but he's also in classes. He's a student, and he came to me with this idea about just doing a short, brief presentation about exoplanets. So we've been talking about planets that we can observe, planets that are part of our history, planets that are kind of associated with our sun and our solar system. But nowadays, we actually have to think about planets and other places. So Armand, welcome to the show. Thank you.
Yes, thank you, Rick. Let me share my screen and let's get started. So I'd like to start by just showing a picture of a bunch of stars. If you live in the city and you look up at the sky, you'll see a few stars. And as you move further away, you'll see more and more. But even then, you're only seeing the tiniest fraction of all the stars that are there in the night sky. Billions more exist, but they're too faint to see just with the naked eye. So when you look at the stars, you might think, are there planets orbiting those stars? And if they are any of them like Earth? And the answer to that is yes. And they're called exoplanets. Any planet orbiting a star other than our sun is considered an exoplanet. They come in a wide range of sizes, with some being many times as big as Jupiter. They come in a wide range of compositions and temperatures. Some of them are so hot that it rains molten iron, and some of them are similar to size in Earth, but have a much larger mass, which leads scientists to believe that they're made mainly of highly pressurized carbon or diamonds. Can you imagine that? An entire planet made of diamonds? That'd be crazy. But there are also almost 5,000 confirmed exoplanets so far. And that's so much compared to what we knew just 50 years ago, where the idea of exoplanets seemed like science fiction. But how do we find these exoplanets? They're all incredibly far away, and most of them are much smaller than their parent star. So seeing them directly would be very hard. But what about indirectly observing them? So we know a star's gravity exerts a force on the planets. That's why they all orbit stars. But what about the planets exerting their own gravitational force back on the star? This is called astrometry. where the star, the host star wobbles slightly due to the planet's gravitational pull on the star. And we're barely able to see that in the night sky, but it's still very, very faint. But even though we can't see it directly, that doesn't mean that it doesn't have something that we can measure. So this gravitational interaction between the planet and the star causes the star to wobble, and it can wobble away from us or towards us. And that causes the wavelength of light that we receive from the star to either go towards the bluer part of the spectrum or the redder part of the spectrum. If the star is moving towards us, the light is blue shifted. And if it's moving towards us, it's red shifted. Another way that we can detect exoplanets is called transit photometry. And this is when a planet passes by in front of the star. But one of the main things to keep in mind for this detection method is that the line of sight between us, the star, and the planet needs to be exactly the same. So this planet needs to move exactly in between the star and us in order for us to see it. If it moves under it, we can't see it. If it moves above it, we can't. But when it moves in between us and the star, it causes a slight dip in brightness of the star that we can measure. And now as technology is advancing, we're able to even image or take photos of planets directly. And the photo you see on the right is a multi-planet star system. But what can we learn from all of these detection methods? By looking at the gravitational interactions between the planet and the star through astrometry and radial velocity, we're able to tell a planet's mass. And by looking at the change in brightness of a star in transit photometry, we're able to tell how big the planet is, or its size and volume. And what happens when you divide mass by volume? You get its density. We know that gases have low density, liquids have a higher density, and solids have a much higher density. And we also know the exact density of ice, different rocks, and different metals. So by dividing mass and volume and getting the density of the planet and comparing that to the densities of objects and materials we already know, we're able to find out the density of a planet, which can be very important in terms of what kind of planet it is, whether it's a rocky world like Mars, Venus, Earth, or Mercury, whether it's a gas giant like Saturn or Jupiter, or whether it's a small icy world like Pluto. And once you bring direct imaging into the equation, you're able to also learn more about the planet's orbit and its atmospheric composition. So just through indirect methods, the first three, we're able to know a lot about the planet without even looking at it directly. And after we are able to directly take a photo of the planet and find out more about its atmospheric composition, we can learn more about what the atmosphere is made of. And this helps us in our search for life. We know that what are some of the important gases for life? We know that we breathe in oxygen, O2, and we give off CO2 or carbon dioxide, and it's the opposite for plants. But I'm taking a course called SES 311, Essentials of Astrobiology, taught by Dr. Ariel Anbar here at ASU. And then I learned that phosphine, or PH3, which is 1 phosphorus and 3 hydrogen atoms, is also an important gas in the search for life. This gas is only produced by microbes and human industrial activity on Earth. So if we're able to look at different planets and see that gas, that could potentially be an indicator of life on those planets. Now, I want to show you some direct photos of planets, or videos in this case, courtesy of Dr. Jenny Patience, one of the leading exoplanet researchers and a researcher here at ASU and the School of Earth and Space Exploration. Here you can see a planet passing by its star. And then in the next video, we can see a multi-planet star system and see the planets orbiting the stars. Isn't that so cool, seeing these tiny, tiny planets, millions and millions of miles away, orbiting their stars, solar systems similar to our own. And now, right as we're wrapping up, I'd like to show you one really cool resource, which is the NASA Exoplanet Archive. This webpage is updated every day, and we can see right here the total number of confirmed planets or confirmed exoplanets, which is almost 5,000. And you can go around and play with this. So let's just click on this right here. And we can see all the exoplanets that have been discovered. Let's just take a look and see how many were discovered in this year alone. And you can take a look and see the count. I think around, let's say 30, 40 planets were discovered this year alone. And you can also see the method of discovery. So yeah, that wraps it up for exoplanets for me. And I'd encourage you to go to this website and play around with it yourself and learn more about worlds like our own. Thank you.
Armand, excellent job.
Rick.
Yeah, thank you very much. Thank you. Excellent job. I think that was really a good synopsis of what we're doing. And I have to say that direct imaging, these are telescopes that are Earth-based that are now actually looking at or seeing or observing planets in formation around other worlds. And I just think if you had asked me 10 years ago, we'd be able to do that. I would say it's impossible. It's never going to happen. But that just goes to show you never say it that way. So. But thank you. And I can tell you kind of really appreciate the subject, and thanks a lot for your contribution. Planets are planets, right? They don't just have to be our own.
Yes, exactly.
So I'm going to just kind of sort of head for the next part of our program. It was really great for us a while ago. We had a guest from Fountain Hills. Sorry about that. Every time I change this, I have to shut the sound down. I'm just going to kind of just introduce you to this thing. I think for those of you that have been following our program over the last couple of weeks, you know, I'm on this campaign to get people thinking about things and thinking about ways to understand the cosmos and understand the night sky and look for those things that connect us to really I call it the true meaning of time. Right? It is that Earth orbiting around the sun that makes everything work. And we as a civilization, it just wasn't that long ago that we were mostly farmers. And we followed the cows because they actually followed the sun and they kept track of what was going on and they sort of adjusted the time for us. And today in our workaday life, in our big cities and the way we kind of motivate around, we're on clock time, not necessarily natural time. And so I've been encouraging people to sort of reconnect in a couple of meaningful ways. We've already covered 3 of these up to this point. So this is review. I'm encouraging people to get to know a constellation, get to know a part of the sky that's at a particular time and revisit it every single year at the same time. Make it around your birthday or make it around your family reunion or make it around some other celebration, but find a piece of the sky, attach it to your annual calendar and visit it and watch it every single year. I encourage people to kind of go take advantage of things that are unusual, not necessarily the regular annual things, but things that happen like eclipses or like meteor showers or comets apparently sometimes appear in our night sky. Sometimes you have to work. I think Alex and I are encouraging you to get up before dawn every morning for a little while, just to kind of look at planets. Sometimes you have to kind of work to do that, but sort of look for that, seek it out, make it happen. Last session, 2 weeks ago, we talked about sort of changing our habits seasonally. And I kind of encourage people to take advantage of farmers markets, eat something that grew under the sun within a couple of days. And because I think your body actually needs that. I think we do sort of redeveloped as human beings, and in our DNA is the cycles of nature. And it's important to do this. We don't have to eat seasonally anymore, but we should. So number 4, that's what we're introducing tonight, is I'm encouraging all of us to be an advocate for dark skies. It's very, very important. All of these things, all of these ways to connect start slowly disappearing and going away if we don't take the opportunity to sort of protect the skies we have and all of that. And that, my friends, is my opportunity to introduce you to Joe Bill. Joe's from Fountain Hills, and he was a participant in the development of Fountain Hills' designation as an international dark sky community. And so, Joe, welcome. And we talked a little bit about before the program. You were on actually for like a full program about a year ago, and we're going to have you back again because some amazing things are happening in Fountain Hills. But how about an update? How's the dark sky community going? What's going on?
Well, thank you, Rick, and I appreciate this opportunity. I'm going to give you a very quick update. It's going to be pretty fast. I'm going to share a screen. I want everybody to fasten their seat belts because I want to get through this quickly before we run out of time. But I'm going to share screen here in a second. Okay. Okay, and we'll pick this one. We got too many screens right here.
I can
And,
looking at 7 monitors at once.
Right, exactly. Let's see now. It's okay, right here. Okay, so now you should be seeing the slideshow, I assume.
Nope, not yet. No, I don't.
No?
Not yet. We're not live yet.
How about? No, it's not showing. Oh, here we go. Got it.
There you go. There you go. Thank you. You got.
All right. So just to go through this real quickly, I want to try to advance the slide here. Okay, now we're having a little problem doing that.
Usually I have to use the little arrow down at the bottom right.
Yeah.
Bottom left. Sorry. A little bit.
Well, you know, that's interesting because I've never had this problem. Here we go. Let me try this. Okay, there we go. Okay, got it. All right. So what you're seeing here basically is LEDs were introduced maybe a number of years ago, maybe almost 10 years ago. But when they first came out, they were all the bright white ones. And those were a problem. They save energy, which is great. But because they were bright white, a lot of the light they were producing was in the blue part of the spectrum. And that's the part of the light spectrum that kind of creates the sky dome. So you can't see the stars. That's why our sky is blue. It's called Rayleigh scattering. So basically, you can see what's happening across the United States. These were taken over a period of a number of decades, starting with satellite photos from the late 50s to mid 70s, mid 90s, and what is anticipated in 2025. And you can see we're losing our night sky pretty rapidly. There aren't many dark areas left. So I have to give my wife credit. She had an idea. She found out that there is such a thing as an International Dark Sky Association, and you can get designated as a dark sky community, get your lighting ordinance changed. And so we formed the Fountain Hills Dark Sky Association and started educating the community about the advantages of smart lighting. And then that led to, of course, a year later, which was timely for us, the American Medical Association weighed in. And basically they determined that the wrong kind of outdoor lighting, the bright white lighting, is actually detrimental to human health. And so that is what they unanimously adopted, is this resolution that outdoor lighting should be 3000 K or less for health reasons. And so that's right in line what we wanted to achieve. That's right in line with what we went to the town council with here. And we did get the lighting ordinance changed so that any future lighting in Fountain Hills now has to follow that standard. And just to let you know what correlated color temperature is very quickly, obviously if it's a lower temperature, the K is for Kelvin, anything below 3000 K is more on the amber side of the spectrum. And it's the bright white lighting that's sure it's good for indoor office settings and things like that, but not at night. And just to give you one little factoid about how they come up with this color chart, it's kind of interesting because what they do is they take a block of iron, and if you heat it up to the temperatures shown here, that becomes the color of that iron block. So that's what the Kelvin temperature does to how a piece of iron will look. So first 3 years, what happened is we learned about the designation, formed the association. In 2016, the town council gave us unanimous approval to update the outdoor lighting ordinance and pursue the designation. In 2017, we fulfilled the requirements of education and 10 lighting projects. So this is an example. One of the projects was to replace all the lighting in the town parking lots. And one night at the end of the day, one of the workers quit when he had changed one of the bulbs on a light pole, but not the other. And so you can see that they were replacing all the bright white lights with lights that are more on the amber side of the spectrum. Another example is right here. A contractor put in new lighting for a small strip mall, had no idea that we had updated our lighting ordinance. And then the top photo, you can see the bright white lights that went in. Was called to their attention and they changed them. And so you can see how smart lighting can make such a difference in terms of not polluting the night sky. And I have to emphasize, we're not against lighting. If you can have street lights, you can have all kinds of lights, as long as they are aimed downward and are on the amber side of the spectrum. They do not create nearly as much of an effect on the light dome that you see over the metropolitan areas. So we did that. We achieved our goal to become a dark sky community. That happened in early 2018, became the 17th in the world. And we received lots of publicity in major newspapers around the country and actually parts of the world because we're so close to a metropolitan area to have achieved this. So we are now, of course, we have signs at our community, entering the community. It says we're an international dark sky community. We're in a Thanksgiving Day parade. We have a festival every year, and I should point out, there's one coming up here in March on the 26th, and hope you can come. It's really a great thing. We have great speakers.
It looks like it goes into the night, so we can actually, so that you can start during the day and watch it get dark in your dark sky.
Exactly, because there was a huge, big star party where some of the astronomers from throughout the valley bring their big telescopes, set them up, and get a chance to see all kinds of things in the night sky. So that plus the presentations, we get the laser tours of the night sky. It's really fun. And there's food trucks and everything. And laser tours of the night sky are always common because we have a number of people who can read the night sky. And as a matter of fact, we have a relationship with a Marriott resort in Fountain Hills. They have a program now where they have a telescope in every suite on the balconies. And then they periodically have some of our people from our board come up there, bring their big telescopes, set them up. And so the guests can come out after dinner and get a look at the sky through the telescope, get a laser tour, etc. And you can see at the very bottom, Marriott refers to them as the star dudes. And so it's kind of interesting because I kind of helped set this program up, but I don't have a big telescope like these other people, and I can't read the night sky quite like they can. So they refer to me as the star dud. So, but I can take it.
There's humility for you.
That's right. So it's all good. One point I really want to emphasize is that our goal is try to reduce the amount of artificial light at night. And it's not just to see, not just to open a window to the observable universe. Yes, that's an important part. But it is very important for nocturnal animals to reduce the artificial light at night. There are hundreds of thousands of birds that stray off course in their migration that are killed every year. And one of the things I like to bring up, because I have a hunch that this is the one thing that's finally going to get people's attention about having too much artificial light at night. Too much artificial light is adversely impacting the nocturnal pollinators for the blue agave. Well, the blue agave, if you don't realize what it's for, is a lot of it is used to make tequila. So I think if we run out of tequila, that might be when people realize that maybe we need to not have so much artificial light at night. But anyway, I just want to make that point. There's a multiple reasons why we want to reduce artificial light at night. The other thing I want to point out too is this is a global movement. This shows you the increase in the number of designated international dark sky places. Now the blue are international dark sky communities, the orange are international dark sky parks, and so on. So the parks like the Grand Canyon, Mesa Verde National Park, Saguaro National Park, those have been designated as international dark sky parks. We are an international dark sky community, but it just shows how this is really taking off worldwide. I also want to quickly mention the Bortle scale. We monitor how bright our sky is every year, and actually we keep track of it more often than that, but we have to report the results every year to the International Dark Sky Association. Our skies here in Fountain Hills actually are pretty good. They're about on the Bortle scale 5. This is the Bortle scale. And of course, Bortle scale 1 means you're probably on top of a mountain in the middle of nowhere. And a Bortle scale 9, you might be downtown Los Angeles. So Fountain Hills is Bortle scale 5, which being this close to a major metropolitan area is actually quite good. So we're happy about that. And it has pretty much stayed the same since we started this process because we are trying very hard to control the lighting here. Lastly, I'll close. I just wanted to mention that hopefully I'll get a chance to talk to you in the not too distant future because we have some very, very exciting things happening in Fountain Hills. We're working on building a 22,000 square foot facility, the International Dark Sky Discovery Center. It'll have an observatory with the biggest telescope in the greater Phoenix area. Can't wait to work with ASU on that because that observatory can do research and have public viewing as well. We'll have a planetarium, an exhibit hall, a theater, and all of it will be devoted to educating people about the importance of reducing artificial light, but also introducing them to astronomy, what's all the things that are out there that everybody should know about. We're very excited about that. So I'll have some new visuals to share in the not too distant future. We'll have 3D flyovers of the facility, et cetera, et cetera. So with that, I hope I didn't go too fast, but I know we were running out of time.
No, I know. No, it's a lot to talk about, and it really supports the big idea. The other thing I'd like to add is Fountain Hills is not that far away. And so as you get this open, or as you have these little parties, as you do the festivals and things like that, this is a very visitable place. You're just not that far out of the Phoenix metropolitan area. And that little bit makes a huge amount of difference with light, doesn't it? I mean, it just, I think about, our university in downtown Tempe, and some nights you can only see 4 or 5, 6 stars. And so 35 minutes later, you could be in Fountain Hills and actually see the whole place.
Well, from ASU, it's more like about 25 minutes.
There you go.
And so it is pretty close. And I think we're just fortunate because we have tribal lands on 2 sides, to the south, to the east, the Tunnel National Forest, and McDowell Mountain Regional Park to the north. And then the McDowell Mountains help shield some of the light coming from Phoenix.
I'm sure if you look out towards the southwest, though, there's a huge glow right in that.
Oh yeah, you can see that glow coming over the McDowell Mountains, and so we know Phoenix is there.
And we do programs up in Payson, and I can see the glow from Phoenix up there. So,
Right.
I just really applaud you guys because you're just working really, really hard. You're citizens and you're a community, and you've put together this really great program. I think it's a great. What did you say? You're the 17th or the 27th? Yes. What was it? The 17th?
17th, yes.
Are you aware that are there any new communities since then?
Yes, actually, they're up to I think almost 40 communities now around the world. They're all over the world. It's really interesting to see the map and see where they are all popping up. So they're on every continent.
Well, I'm glad you're taking it on. I'm glad you're preserving a night sky because it's a big deal. So thank you, Joe. Thank you very much for the update. We'll definitely have you back. I am also going to take this opportunity to close and just, the only announcement I have for everybody tonight is that 2 weeks from now, we'll be back. And we've decided to really just turn 2 weeks from now is about education. on all levels. It's about mentoring. It's about kind of taking what we know and delivering it to the next. And so we have several teachers that are going to join us, and several people that work in the education community, and they're all about working with kids, working with citizens, working with adults, and that's going to be our focus 2 weeks from now. So I hope you'll come back and join us for that. I thank you. I know we went over a little bit, tried to cover planets tonight, and so get up in the morning, get up before dawn, and check out what's going on in the sky. Especially watch for a little while, watch Venus and what it does and how it acts in the sky. It's very special and very fun to see. All right, thank you everybody. We'll see you in 2 weeks. Bye-bye.